In this module we learn about function parameters. I'll define a function parameter for you by saying that it's actually possible to give a function a piece of data via their command line, and those functions can then, if they want to, use that data in their processing. And the data that you specify on the command line is of course called a function parameter. Now let's do a quick recap on command lines. If I was to run the command ps, for example, which I do know happens to be an executable file, then I see the following output. I can run the ps command again, and this time I can specify a parameter, and the parameter that I'm specifying is the -f parameter, which modifies the function, the behavior of the ps program in the following way. The key words that I use then are that the -f parameter modifies the behavior of the ps program, and in the same way we're going to use function parameters in the same way that I've just demonstrated program parameters. We're going to specify them on the command line, and they will modify the functioning of the function that we specify. Let's look at an example of that. This is the example from the last module, or the one before that. Now notice that this is a function called backup_1_file, and its sole purpose in life is to copy a particular file to a backup directory and then let us know that that has actually happened. It works as you might expect any function to work, except there's one very important little addition, and that is the use of the symbol $1, which looks like a variable, and it kind of is a variable, except it's not a variable that you can actually set yourself. It's called a read-only variable in the sense that you can only read from it, you can't write to it. And what it does is it actually represents the first parameter that was passed to this particular function on the command line. So when we have a look at the command line, you'll be able to put all the pieces together and see the whole picture. So it might actually be called like this. Here we've actually called it twice. We've called it once with a file name called report.txt, and we've called it a second time with logo.gif. Each time we have specified a single parameter, which the first time is report.txt and the second time is logo.gif, and each time that that function is called, the parameter is actually copied into $1. So in the actual function, when the function runs, the very first line that runs in the function is the CP line. So it will actually read the first time CP space report.txt and then a space and then the backup dir, and then it will echo report.txt has been backed up. And then the second time it runs, it will be CP logo.gif to the backup dir, and logo.gif has been backed up. So you can see there's a substitution going on here. It's almost like there's an explicit variable assignment taking place. It's almost like someone's going 1 equals report.txt, and then the second time 1 equals logo.gif, and then we'd obviously be treating 1 as the name of a variable so that we can use $1 to extract the contents of that variable. That's kind of what is happening under the bonnet, but we can't actually see that happening. Okay, so let's have some more information about that. There are actually 9 possible parameters that can be individually referenced for any one function. You can actually specify as many parameters as you like to a given function, but you can only reference the first 9 of them individually, and of course you do that by using $1 to $9. We will see in a later chapter how to actually access the ones beyond that individually. There is a way, but it's a little tricky. You can get to the 10th, 11th and 12th variables and so on, and we'll also learn in just a moment how to access all the variables, all the parameters collectively. But I want you to note before we do that unlike many programming languages like C or Pascal or so on, there's actually no reference to a function's parameters on that function's declaration line. Now if you're not a programmer, you won't know what that means, and that doesn't matter, you can kind of ignore that. But if you are a programmer, you may be used to seeing on the very first line of the function some indication about how many parameters the function takes, and even perhaps what type those function parameters ought to be. And well, I'm here to say that you don't get that in the shell. There is simply no parameter checking done whatsoever. You can call a function with as many parameters as you like. If that function is expecting 3 parameters and you only give it 1, well, it's your job to actually test how many parameters have been passed and to perhaps put out an error message if it's wrong. So I'll show you now how to do that. There are some handy shortcut variables that are created for us by the shell, and they are as follows. $* actually represents all the parameters that have been passed in on the command line, so you can do things with all the parameters at once if you need to. And there actually may be hundreds of them. That is possible if, for example, the function was called with parameters being all the files in the current directory, and maybe a big directory. The second shortcut that we have available is $# or $pound, and that represents the number of parameters. For example, you might get 4 parameters. So you can actually use that in an if statement to determine whether you've been passed the correct number of parameters. It's very simple. You'd use that with test, so you'd say if test $# is greater than 3, or whatever it's supposed to be, then you can print out an error message or do whatever you like. And there's one final shortcut that's used with function parameters, which I'll now show you, and that is in conjunction with the for loop. It's actually useful to create a for loop that loops once through each parameter that the function receives on its command line. So the code looks like this. We have a function called backup these files, which we're going to assume takes several parameters on its command line, as you can see in the last line, where we're calling it with star.txt and star.doc. Now, incidentally, how many parameters is backup these files actually getting? How many parameters are there on the command line? Well, the answer is surprising. It is not 2. If you said 2, you'd be mistaken. Well, it's not necessarily 2, I should say. Let's say there were 5 files in that directory that ended in .txt, and there were, let's say, 6 that ended in .doc. Then backup these files, the function would actually receive 11 parameters, because what would happen would be the shell would process that command line first. The backup these files star.txt, star.doc command line would be processed by the shell first, who would do all the wildcard expansion, and so you would end up with 11 parameters to back up these files. Anyway, the key point about this is the very first line inside backup these files is for fname. Now remember, we're doing a for loop here, so what we expect to see is for fname in something. But the lovely shortcut that we have here is that we don't actually have to put in anything. We can just say for fname, and what it will do is it will loop through the code block, and each time fname will be assigned to the next command line parameter that the function received. So the first time through the loop, fname will be set to $1, and the second time through the loop, fname will be set to $2, and so on. And even if there's more than 9 parameters to the function, like in this case I just said there might be 11, it still works. So in this particular example, we would get 11 different copies followed by 11 echoes. If you really wanted to be explicit about the for loop, you could actually write for fname in $. Remember, $* represents all the parameters on the command line, so that would work as well, but it's just not necessary to put the in $* there at all. So let's have a look at that in action. So here's that same code, essentially written into a shell script. I've only made 2 modifications. One is I've actually copied them to the temp directory, and the second modification is I'm just going to back up the files that end in .dat. And there are, in fact, 2 files in this directory that end in .dat, names.dat and places.dat. So let's run it, back up, and I get names.dat has been backed up and places.dat has been backed up. So it would be fair to say that the for loop is actually looping through each of the parameters successfully on the command line.